Hello friends, this video on structure of atoms part 5 is brought to you by examfear.com. No more fear from exam. Now we'll talk about some concepts of different shells of atom as explained in the Bohr model. So you see hydrogen, there is one shell, helium there is one shell, lithium there is two shell, beryllium 2 shell, boron again 2 shell, carbon 2 shell, sodium 1, 2, 3 shell, magnesium 1, 2, 3 shell, aluminum 1, 2, 3 shells. So all these atoms look different. So we'll now explain in this what are these shells. So these are the orbits which Bohr talked about, and he told that the electrons will move in this orbits and they'll not lose energy. If you see, there's one electron here in the first orbit, helium 2 electron in the first orbit, lithium if you see 2 electron in the first orbit and then 1 electron in the second orbit, beryllium 2 electron in the first orbit and 2 in second, boron 2 electron in the first, 3 in second, carbon 2 electron in the first, 4 in second, nitrogen 2 electron in the first, 1, 2, 3, 4, 5 in second. Similarly, oxygen 2 electron in the first orbit, 1, 2, 3, 4, 5, 6 the second. Fluorine 1, 2 electron in the first, 1, 2, 3, 4, 5, 6, 7 in the second. Neon 2 electron in the first and then 8 in the second. Right, so this first orbital is called K, second is L. So this is K and L. Let's talk about sodium. 2 electron in the first orbital, that is K. The second orbital has 8 electrons, you can count, and the third has 1. So K, L, M. These are the orbitals, and it has 2, 8 and 1 electrons. Similarly, aluminum 2 in the first, 8 in the second and 3 in the third orbital. So K, L, M will have 2, 8 and 3 electrons. Okay, so there are rules to write these electronic configuration. So electronic configuration is nothing but you tell the configuration of electrons. Electronic configuration, as the name suggests, electron configuration. Right? How many electrons in which shells? So it has been seen that different shells will have different number of electrons. Okay, so there are some rules for that. Right? This is in line with the Bohr theory, which says that this is the structure of atom and electrons move in different orbitals. When they move in these orbitals, they don't lose energy, but when they move from one orbital to another, they lose or gain energy. So when it moves from lower to higher orbital, it needs energy. When it moves from higher to lower orbital, it emits energy. Okay, so there are some rules to determine the electrons in different shells, and different shells are K, L, M, and like that. It starts with K. This is the convention we have. So the maximum number of electrons present in a given cell is given by 2n square formula. See, for K, n is 1. So 2 into 1 square is 2. For L, K is 2, n is 2. 2 into 2 square is 8. M, it is 3. 2 into 3 square is 18. N, it is 4. 2 into 4 square is 32. So K, L, M, N. So K will have at the max 2. L will have at the max 8. M will have at the max 18. N will have at the max 24 electrons. That is the maximum number. Please note that is the maximum number of electrons. You see, hydrogen, only K orbital has 1 electron. The maximum is 2. Helium, it is 2. This is 1. Talk about lithium, it's 2, 1. K has 1. L maximum can have 8, but here it has only 1. Talk about oxygen, it is 2, 6. So L can have at the max 8, it has 6 now. Neon, 2, 8. L can have at the max 8, it has 8 maximum value. It cannot have more than 8. Okay. The next is the maximum number of electrons that can be accumulated in the outermost orbital is 8. So if you see any outermost orbital for a given atom. So for hydrogen, outermost orbital is 8, K. For helium it is K. For lithium it is L, right? Because there are 2 orbitals. For sodium it is K, L, M orbital. Right? So for any atom, the outermost orbital will have at the max 8. That's the extra rule. Right? So you first just see K, L, M, N. So K will have 2, L will have 8, M will have 18, N will have 24, like that. But if M is, let's suppose, the outermost orbital, then it will have at the max 8 electrons. If N is the outermost electron orbital, then N will have at the max 8 electrons. That is the rule, right? And electrons are not accommodated in a given cell unless the inner shells are filled. That is, the shells are filled in the stepwise manner. For example, I have to fit in 3 electrons of lithium. So the first 3 electrons of lithium. The first electron will go to K. The second electron will also go to K. K is filled because K will have at the max 2. Third electron will go to L. Let's do for sodium. For sodium has 11 electrons. First electron will go to K. Second will also go to K. K is filled. K at the max can have 2. Third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. These electrons will come to L. L will be filled with 8 electrons. So I'm done with 10 electrons. The next 11th electron will go to M orbital. So it will be 2, 8, 1. And you will see for sodium, 2 electrons in this orbital, 8 electrons in this orbital, 1 electron in this orbital. Okay. So we'll see some electronic configuration of some of the prominent element. For example, hydrogen, K has only 1, L, M, N is blank. Helium, K has 2, L, M, N is blank. Lithium, K has 2, L has 1, M, N is blank. Similarly, beryllium, K has 2, L has 2, M, N is blank. Similarly, let's see oxygen, K is 2, L is 6, M, N is blank. Like that, you write the electronic configuration. Okay, and if you see when you talk about a distribution of electrons, you take this number of electrons. So if it is 1, it is 1, 2, it is 2, 3, 2 plus 1, 3, 4, 2 plus 2, 4, 5, 2 plus 3, 5, 6, 2 plus 4, 6, 7, 2 plus 5, 7, 8, 2 plus 6, 8, 9, 2 plus 7, 9, 10, 2 plus 8, 10, 11, 2, 8, 1, 11, 2, 8, 2, 12, 2, 8, 3, 13, 2, 8, 4, 14, 2, 8, 5, 15, 2, 8, 6, 16, 2, 8, 7, 17, 2, 8, 8, 18. So that is how it is. It is electronic configuration. That is nothing but the configuration of electrons. So it should match with the number of electrons. Okay. So as we have seen, typically the atomic number talks about number of electrons. See, you will see always that atomic number is number of electrons and number of electrons will be equal to number of protons to make it neutral. The number of neutrons may vary. We will see this kind of situation. Okay. Let's take some question here. Write the distribution of carbon electrons in the carbon and sodium atoms. So let's take carbon and sodium. Carbon atomic number 6, number of electrons is 6. Sodium 11, number of electrons is 11. So let's start with carbon. KLM. K can have at the max 2, L can have at the max 2 square into 2 is 8, M will have 3 square into 2, that is 18. So we have 6 electrons, 2 will come here, 4 will come here for carbon. For sodium, 11 electrons, 2 will come here, 10 pending, 8 will come here, 2 will come here, 9 pending, 8 will come here, 1 pending, 1 will come here. So for carbon it is 2, 4, for sodium it is 2, 8, 1. That is the electronic configuration. Okay. So this is my carbon. You see 2 and 4. Sodium 2, 8 and 1. Okay. So if K and L shell of atom are filled, then what would be the total number of electrons in the atom? So as K is filled, L is filled. What is the total number of electrons in the atom? See, K and K can have at the max 2, L can have at the max 8 electrons. If K is filled, K has 8. L is filled, L has 8. Total number of electrons is 10 electrons. The number of electrons in the atom is 10. Pretty easy. Now, thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.